This is episode 2 of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs, and practice exams. This is a router. But what is it? Routers connect us to the internet. They also connect us to other networks. In this video, we're going to see why we need them and what they do in our networks, and why I have so many of them. Holy junk sauce. And of course, we're going to be labbing. We're going to watch how a frame and then a packet will go across a network, access a web server, and then give us information back. This is how the internet works. You're going to learn that today. Let's get started. Oh, and by the way, I'm giving away some Boson NetSim today on this video. Don't know what NetSim is? What's the best CCNA and CCNP labbing software in the business? So if you're going for your CCNA or CCNP Enterprise or anything that you're doing in Cisco, it's what you want, it's what you need. I'm giving away 5 copies of any of those products. Link below to enter the contest. Hurry up, it's going away soon. Johnny wants some coffee and we're gonna help him get it. Check this out. In our last video, we talked about this guy right here, a switch. He's got multiple ports, you connect your computers to him and they can talk. And that's exactly what's happening here. Johnny, Mark, Denny, and Lisa are all on the same network, and the switch allows them to talk to each other. And in our last video, we explored how the switch actually helps them talk. What goes on inside this thing. And it's pretty cool. But you see now Johnny, this is Johnny in real life, he's a Raspberry Pi. Johnny doesn't want to just talk to Lisa, Mark, and Denny. Johnny wants coffee. The coffee is actually way over here, on a completely different network. And Johnny's over here. Not good, right? How does Johnny get coffee? And when I say Johnny wants coffee, of course he wants to go out to networkchuck.coffee and order some coffee. But this server, where this website lives, networkchuck.coffee, is on a different network. Here, the switch can't help him. He needs help from somebody else. He needs a router. This guy right here. Oh, this guy. This is a Cisco 2911 router, one of my favorites. Oh, it's beautiful. Now, routers come in all shapes and sizes. This is just one type of Cisco router. This is a Ubiquiti router, looks very different. And then typically your home routers look nothing like what I just showed you. A router is the perfect solution for this because a router's job is to connect networks. Let's put one on there. This is actually a virtual version of a 2911 router. Look, just like the one I showed you. How neat. So we'll put the router in between. And notice on a Cisco router, there's no ports on the front. They're all in the back. So let me turn that sucker around. Now plug Johnny's switch in to the router, and then I'll plug the coffee network into the router as well. Let's do that in virtual world. Bam, bam, and once more. Now before we keep going, I want to ask you a question. Do we actually need this router? I mean, why can't we just do this? Let's take away our connections, move this router out of the way, and then let's just connect our switches directly to each other. That should work, right? No, it won't. Here's why. I mean, we could connect these two switches and make them one giant switch, and that's essentially what would happen. But the reason these guys over here and then my coffee server over here are on different networks isn't because they're connected to 2 different switches. That's not it. It's because of these guys right here. Their IP addresses. We will go more in depth on this later because there's a lot more to it. But just know that when we talk about a network, we're normally referring to IP addresses and a group of IP addresses. So notice I have 2 groups of IP addresses here. 10.1.1.0 through 10.1.1.255. With my configuration, as long as you have an IP address in that range, you're on the same network. Now this right here, 23.227.38.0 through 23.227.38.255, that's a completely separate network. But you know what? Don't take my word for it. Let's actually try this. Let's see if it'll work. Let's go back to Packet Tracer. Now, as a quick 30-second refresher on how a switch works, we'll have Johnny try to ping Mark over here, and then we'll have him try to ping my coffee server over here and see what happens. So I'll click on Johnny, wake him up. Come on, Johnny. Let me get this stuff out of the way. We'll go to his desktop, we'll go to his command prompt, and let's bring up a simulation real quick. So we'll click on the simulation button at the bottom right, so we can watch this stuff happen in bullet time. And I'm going to show you something that I did not show you on the last video, and that's how Johnny will learn Mark's MAC address. Now, why is it so important for Johnny to learn Mark's MAC address? Well, if you recall from our last video, the switch, the only language he speaks is layer 2. That's all he knows. MAC addresses, this layer 2 address right here. Now, when Johnny pings Mark, he's going to be pinging his IP address. So his message, when he gets it ready, will be pinging 10.1.1.2. If Johnny were writing a letter, that's what he would put as the address. But if that's all Johnny had when he sent this message to the switch would be like, why is this envelope blank? I can't even see IP addresses. Who is this going to? That's what would happen. So Johnny must know the MAC address of Mark in order for the switch to know how to get it to anywhere. But how? this is what happens. So from Johnny, I'm going to ping Mark's IP address, 10.1.1.2, and boom, let's watch what happens. All right, Johnny's got some envelopes. He's ready to send them out. These are frames right now. Notice we have a new message we're dealing with. It's called ARP, or Address Resolution Protocol. Essentially, it's a way that Johnny can find out what MAC address is tied to 10.1.1.2, because he has to know that to be able to send it to Mark. Let's open that up and see what's inside. Let's click on that. And again, we're dealing with layer 2 MAC addresses, but also notice down here, we have some information about this ARP packet. Like for example, the source IP is Johnny's source IP 10.1.1.3. And then the destination IP right here, 10.1.1.2, that's the missing MAC address. He's trying to find out Mark's MAC address. And then of course, because this is a layer 2 frame, we're talking about MAC addresses, so the source MAC address that the switch will use is Johnny's MAC address. But then look at the destination. What the junk is that? FFFFFFF. This is what's called a broadcast address. It's the layer 2 switch equivalent of someone going, who belongs to 10.1.1.2? When he sends it to that MAC address, it's going to go out to everybody. Watch what happens. We'll click next. It goes to the switch. Let's open up that packet and take a look. Or frame, I'm sorry. See, it happens. And look at this, this is so cool. So over here, the switch receives it, and then it's about to send it out. And notice it's gonna go out all these ports on layer 1, which remember, layer 1's the physical. It's these, I just unplugged something. Oh, that sound. It's all the physical stuff. So let's click next, and boom. ARP messages going everywhere. And what will happen is Lisa will go, oh, I'm not 10.1.1.2, and neither am I, says Denny. But Mark, yeah, Mark is 10.1.1.2. So he says, hey, that's me. I'm your guy. I'm over here, Johnny. So we'll step forward in time. Mark is the only one who responds, saying, yes, that is me. So he'll send, and then the switch sends that to Johnny. So Johnny now knows Mark's MAC address, so we can send him a ping. If I open that frame up that's sent to the switch, we see the source is Johnny's MAC address and the destination is Mark's MAC address. And if we click continue, it'll go to Mark. Mark will respond. Bam, Johnny gets it. If we check our terminal real quick, our command prompt, it's happening. And if you click real time, it will just continue. So that's what happens when someone's on the same network. Johnny knows that Mark is on the same IP network. But what happens when Johnny tries to get to the network coffee company? Let's see. Let's have him ping it. So we'll open up Johnny once more here. Go to his command prompt. And we'll ping the IP address of my coffee server. So ping 23.227.38.65. Let's go to our simulation so we can watch this in real time. And let's hit enter. Boom. Okay, so far so good. We have an ARP frame that Johnny's getting ready to find out where my coffee server lives, maybe his MAC address. Let's open it up and see. Click on that message. And, do you notice anything weird here? You know what? Pause the video right now and see if you notice anything that might be strange. Unpause. Okay, here we go. So just like before, Johnny's sending a frame to a broadcast address to say, hey, who's got this IP address? But he's not asking about the IP address of my coffee server. No, look here. This is a source IP. This is his IP address. But he's trying to discover the IP address, or the MAC address rather, of 10.1.1.1. Why? Because when he tried to find out Mark's MAC address, this right here was 10.1.1.2. That was the destination. Why is this different? Because Johnny knows. Johnny knows the coffee server is not on his network. So he's not even going to try to connect to that coffee server on layer 2. He's not going to try to discover his MAC address. He gives up immediately. Watch what happens. Let's step forward in time. So Johnny sends this ARP message saying, anyone out there, are you 10.1.1.1? And the switch will send this out. And as we step forward in time, stepping forward, no one responds. Johnny keeps sending out ARP requests. Does anybody have 10.1.1.1? Does anybody have it? And no one responds. Who is 10.1.1.1? And why is Johnny trying to talk to him? Let's find out. It comes down to how we configure Johnny. Let's open up Johnny real quick. Go to his config, and the answer is right here. There it is. 10.1.1.1 is his gateway. Gateway is another word in the networking world we use for router. As I said before, Johnny knows that people in his network are 10.1.1.0 through 10.1.1.255. Johnny knows that if anyone has an IP address in that range, they're in his network, they're in his neighborhood, he can just walk over and talk to him, find out where they are. Like, yeah, I know Bill. He just lives 2 doors down. I can walk over there and talk to him. But if Johnny tries to reach an IP address outside that range, he knows it's not in his network, and he's going to need some help. He needs help connecting to a different network, and that's where a router comes in. So let's throw the router back in there and have some fun. This is going to be so cool. Watch this. Now, before we move on, it's important for you to know that I did pre-configure this router. Not a crazy amount of configuration, but I did add some configuration to make this work. For the most part, switches work out of the box, no problem. A router is a bit more complicated because it has to know how to route between networks. He's a router. He has the map of how to get to things. I'll show you what I mean. Check this out. We're going to have Johnny here once again try to ping networkchuck.coffee. Let's open up his command prompt. So I'll go to his command prompt. We'll go back to our simulation. We're in simulation mode, bullet time mode, and let's watch some crazy router magic happen. So we're going to ping the coffee server and go. Now, same story as before. Johnny knows that this is not on his network. He knows that Bob lives in another state, and he can't just walk over there. He's like, I got to use my gateway. I got to find my router, and his router will be connected to his network. Watch what happens. Let's step forward in time. The ARP message is sent out to the broadcast. And keep in mind, the same reason that Johnny's sending an ARP packet for the router is the same reason he had to send one for Mark. He doesn't know the MAC address for 10.1.1.1, and he must know the MAC address so the switch will know how to get his stuff to the router. The switch sends it out to everyone, and Lisa, Denny, Mark, this server right here, which I'll talk about here in a moment, they're all like, yeah, that's not me, but then the router's like, that's me. I'm 10.1.1.1. And he sends a reply back saying, yep, that is me. The switch tells Johnny, hey, this guy lives here. That's his address. Walk on over. So Johnny does. If we open up that frame that just arrived at the switch, we can see the source is indeed Johnny, and the destination is the router. And then we'll step forward in time, it arrives at the router, and then we have something blinking and flashing. Let me zoom in on that. This is so cool. What's happening right here? Well, let's open up the freaking out guy right now. Isn't networking fun? Oh my gosh. Okay, here's what's happening. Now, what did the router receive right here? Well, if you just look at layer 1 and layer 2, we know that he received this frame on his gigabit 00 interface, as this little message says right here. But because we have layer 3 involved, we know that to be called a packet, remember? That's what routers do, man. They are all about layer 3. They are layer 3 devices. They can handle the IP addresses. That's the language they speak. So this is what the router received. Notice it's from the MAC address that belongs to Johnny right here, and it's to his interface. But then look at what he's sending out, and notice what's missing. Layer 2. Now, according to his layer 3 map, he knows that 223.227.38.65 is that way. But that's layer 3. He doesn't know where he lives at layer 2, and because he's about to send this frame to the switch, he doesn't know how to tell the switch how to get to him, and that's important. And that's the reason we have this freak out message, like, I don't know what his layer 2 address is. So how does the router find out? Well, how did Johnny find out? An ARP message. He says, hey, where is 23. Blah, blah, blah? And he broadcasts that out. Watch. Right next to the freak out message, we have the ARP message right here. From the router to the broadcast, and we're looking for anyone that has this IP address. Anybody got this? Anybody out there? And let's step forward in time and watch this happen. So he sends the ARP message to the switch broadcasts it out, and because the server is the only one that is on the network, he receives it. The server's like, hey, that's my name, that's me, I'm over here. So he sends the response to the switch. The switch is like, yeah, I know where this guy is. Hey, router, I found him. And now that everyone knows where everyone is, Johnny's ready to send his message. So if you open up Johnny's message over here, I want you to pick up on this. In the layer 3 header, Johnny has his IP address as the source, the coffee server as the destination. But on the layer 2 level, we have his MAC address as the source, and then the destination is the MAC address of the router. So layer 3 right here is directions for the router, saying, hey router, this is where I want my message to go. And then layer 2 right here is directions for the switch, saying, hey switch, this is where I want my frame to go. It's going to go to the router, and the router will take care of the rest. Let's watch it happen. Step forward in time. The switch receives it. If we open that message up, we can see it's only layer 2 because the switch can only see layer 2. It's going straight to the router, so he sends it to the router. This is so cool, isn't it? I mean, it's amazing. Let's open up that router's message and look at that. This is the message he received. So layer 2, it's from Mark's MAC address to his MAC address. Layer 3, it's from Mark's IP address to networkchuck.coffee's IP address. And now for the outbound message, because he learned where the coffee server's MAC address is, he can send it out. So here's the layer 3. And then for the switch, he's got the directions right here. From his MAC address to the coffee server's MAC address, which ended in 1AC7. If we look at that, yep, it matches up right there. Let's watch it happen. Boom. The switch sends it out, and the coffee server got it. And then the coffee server replies and sends it back. The router sends it through, the switch gets it, and then Johnny gets it. Isn't that amazing? And this happens millions of times every day across networks across the world. Isn't that just crazy? Now, I want to show you one more thing. It's kind of a sneak preview to what we're going to be talking about later. But obviously, Johnny, he wants to order some coffee from networkchuck.coffee, but you can't order coffee by just pinging the web server. You have to visit the website, and we can do that. Let's have Johnny do that right now. So I'm going to reset everything and we'll get this thing ready. This is going to be amazing. Don't let this overwhelm you. We will go over the details of how this works later on, but I just want to show you because it's so neat. I can't help myself. So we're still in simulation mode. Let's open up Johnny real quick. And instead of going to the command prompt, we can go to his web browser. So I'll click on web browser right there. And the website is networkchuck.coffee. Now the main difference here is that we're not using an IP address, at least to start with. It's this friendly name that we normally use, like facebook.com, youtube.com. But how does that work? We know the switch loves MAC addresses, and that's what he talks. That's the language he talks, layer 2. The router loves layer 3, IP addresses. Who deals with names like this? Well, the short answer is no one. Johnny must know the IP address. Or rather, Johnny's computer must know the IP address. So when he types this networkchuck.coffee URL in, there's got to be some way that his computer can find out what the real IP address is, which we just pinged moments earlier. That's called DNS, and that's what our DNS server here is for. Let's watch it happen. I'll click go, and boom. Oh, whoops, I forgot to configure the DNS server. If I go to config, under his default gateway, we have DNS server, which stands for domain name service. And I'll put in the IP address of our DNS server up there, 10.1.1.50. This guy right here. So let's go back to our web browser and try it again. Go. And here we go all over again. We have another ART packet because Johnny needs to get the information on networkchuck.coffee. He needs to learn the IP address, and he knows that this server, the DNS server, knows that information. That's 10.1.1.50, and that's his first job. So he has to go through the process again of learning the MAC address of the DNS server. Let's walk through that now. Stepping forward in time, sends an ART message. The switch will broadcast that to everyone. The DNS server responds because that's his IP address, and he's like, here's my MAC address, that's me. The switch sends that to Johnny, and Johnny's like, yes. So now Johnny can send his DNS query to find out where networkchuck.coffee is. What's the IP address? So he'll get that message ready. So he sends it out. It goes to the DNS server. We'll take a quick little peek inside that real quick. We'll open that up. And a lot of stuff going on there. That's the other layers we'll talk about. Don't worry about that. But essentially the server's like, yeah, I know where that is. Here you go, Johnny. Here's the information. So he sends it to the switch. The switch sends it to Johnny. Johnny learns where this is. Now let's open it up real quick. I'll show you. Let's open that up. And we'll go to the inbound PDU details. Again, don't worry about that just yet. We'll scroll down all the way to the bottom. We can see that the information, the DNS answer, is right here. The name, networkchuck.coffee, and then here's the response, the IP address of our server. So we'll step forward in time. Johnny will send his HTTP GET request, we'll cover more on that later, to the router, to the switch. Now what you might be noticing is that we didn't go through the whole process of learning the MAC address of the router, and the router learned the MAC address of the coffee server. No, it remembered. It puts that in its cache, and it stores it. So we don't have to do it all over again. Now, it will eventually forget that information so it can relearn it. But again, more on that later. So let's step forward in time. It goes to the server. The server gets it, responds back, and you know what? I'm going to switch to real time. Let's open up our web page, and there it is. You need to drink coffee right now. And there's our website. As you can tell, it's been expertly designed. And by the way, that's real. If you want to buy my coffee, networkchuck.coffee, it's delicious. It's what I'm drinking right now. It's real. Now, I've got this lab in a link below. If you didn't follow along with me throughout this, go ahead and open it now and try it for yourself. It's really cool to walk through all this and just see it happen. Like, this is how the internet works. This is what happens when you get on your computer and you go to youtube.com. This process happens. This right here is your home router. You're Johnny. Now, the real internet isn't this simple, right? The real internet is going to be like this router connected to another router, connected to another router, connected to another router, and then eventually getting to my coffee website, as we covered in the first video. But the process is still the same. The router is connecting these two separate networks. And remember, when I say network, I'm referring to the IP addresses, layer 3. These guys over here have a different group of IP addresses than these guys over here. Your home network will be a different group of IP addresses from the rest of the world. And that's why you need a router to connect to the internet. And inside of this router's brain, if you pop him open, he has a map to other networks and to the internet. Like, let's take a look. Let's have you enter another Cisco CLI command right now. Let's pop it open. Let's do this. I'm going to click on the router. We'll jump on over to his CLI tab. We'll hit enter and then type in enable. To see his map of IP addresses and where to reach different networks, we'll do show IP route. This is a command that network engineers use all the time. You're already doing networking right now. Let's hit enter, and boom. I'm going to expand this out a little bit here. And this might look a little overwhelming, but here's all it's saying. The group of IP addresses that Johnny belongs to is right here, 10.1.1.0/24. That's just a shorthand way referring to 10.1.1.0 through 255. And in the router's map, he knows that it's actually directly connected to his interface, Gigabit Ethernet 1. Or I'm sorry, 00. And the same goes for my coffee network over here. There's the network, and again, it's a shorthand way of saying 23.227.38.0 through 255. And that's actually directly connected to Gigabit 01. So when Johnny said, hey, I want some coffee, I want to order it right now, and he sent his packet to the router saying, here it is, I want to go to this guy, the router's like, oh, well, let me check my map. Oh, there it is. There's the network. It's actually connected to my gigabit 01 interface. I'm going to send it out that interface. That's how the router knew. Now, this is very simplistic routing. Routing gets crazy. Like if you were to look at a router on the internet. You know, let me show you real quick. This is actually one of the routers on the internet. Check this out. I'll enter the command show BGP, which is a routing protocol. We'll learn more about those later. IPv4, unicast, and let's see what we got. And all of these are routes to different networks on the internet. Like I can keep going. I mean, look at this. This is insane. This is this router's map. This router is probably huge, very expensive router. But this is an example of A, how big the internet is, and B, what a router can do. Why it's so powerful. All right, we'll never reach the end of this. I'm just gonna stop. And that was episode 2. Now I changed it from days to episodes. Makes more sense for me. If you have any comments or questions, let me know below. I would love to hear your feedback on this. And if you need help, don't be shy. Ask some questions below. Either myself or some others will join in and help you out. Or hey, join my Discord. We've got so many professionals in there who are willing to help out with really any questions you have. And if you want to help me do more of this, create free training along with David Bombal, check out the This Is IT membership, link below. By joining, you help us create more free content. There's also some amazing content on the site for myself, David, and others coming very soon. Not to mention, if you're a This Is IT Army member, you're gonna have your names at the end of this video, so look at it. And if you haven't already, try some Network Chuck coffee. The official coffee of the CCNA. I'm gonna claim it. That's what's happening right now. And of course, a huge thank you to Boson Software for sponsoring this free CCNA course. They're the reason this can be made free. So go check them out and enter my contest below. All right, that's all I've got. Episode 2, done. I'll see you in episode 3.